We look up into the endless dark and ask the oldest question, are we alone? This feeling of cosmic solitude drives us. It sends our probes and our dreams across the void, sifting the red sands of Mars for the fossil of a single cell, listening to the static of distant stars for a single, intelligent whisper. We are explorers defined by our search for a mirror in the cosmos. But what if the most profound mirror, the most terrifying reflection of ourselves, isn't millions of light years away, but right next door? Consider our world. This isn't just a planet. It's a living system, a chaotic, beautiful, unbroken chain of existence stretching back nearly 4 billion years. From the vibrant shimmer of a coral reef to the complex hum of a sprawling city, it's all one sprawling, interconnected story. We call this home. We call it life. And in our search for others, we carry this pattern with us, convinced that this is the blueprint for existence. For decades, our hopes have been pinned on the red planet. Mars is the romantic candidate, the almost Earth that captures our imagination. We see its vast canyons as ancient scars, its dry riverbeds as a promise of a once watery past. It's a story of gentle decline, a world that tried but failed, freezing into a dusty, red memorial. Mars is a tragedy, but it's a comfortable one. It's a ghost that asks nothing of us. But there is another neighbor, closer, brighter, and almost perfectly our size. Venus, the morning star, veiled in elegant, pale yellow clouds. On paper, it is the most Earth-like planet in our solar system. A world of similar mass, similar gravity, and similar composition. It should have been our twin, our sister world. Yet we rarely look. We turn our cameras away, because what we found beneath those serene clouds isn't a gentle memory. It's a nightmare. Let's peel back that veil. Imagine a journey into hell. The atmosphere itself is a suffocating blanket of carbon dioxide, 90 times thicker than our own. The pressure is so immense it would crush a nuclear submarine like a tin can. The clouds aren't water. They are droplets of corrosive sulfuric acid. Winds whip around the globe at over 200 miles per hour. And as you descend through that toxic smog, you reach the surface. The temperature at the ground is over 900 degrees Fahrenheit. It is hotter than the inside of a blast furnace, hot enough to melt lead. The landscape is a jagged, volcanic wasteland, baked and sterilized under a sky that isn't blue, but a suffocating, sulfurous yellow. This isn't speculation. This is data. The few heroic Soviet probes that managed to land there survived for less than 2 hours before they were simultaneously crushed, melted, and dissolved. Those fleeting images they sent back are the only postcards we have from this underworld. They show a landscape of cracked, flat rocks and an oppressive, glowing heat. This is a world that has died. But it did not die the gentle, frozen death of Mars. It died a violent, agonizing death by fire. It is, by every metric we have, a fully realized planetary inferno, the most inhospitable surface in the inner solar system. Faced with this horror, our science has settled on a simple story. Venus is a failed Earth. Cautionary tale. A planet that formed just a little too close to the sun, triggering a runaway greenhouse effect that sterilized it from the beginning. It's a simple, comforting explanation. It puts Venus in a box, labeling it as a never was. But what if that story is completely wrong? We call Venus our twin as a geological curiosity, a reference to its size and mass. But what if that term is more accurate than we could ever dare to imagine? What if the hellscape we see today isn't the planet's original state? What if this 900-degree, acid-drenched, high-pressure oven isn't the story of a world that failed to become like Earth? What if this is the story of a world that was Earth? What if we are not looking at a sterile rock, but at a planetary grave? A world that, for billions of years, was a paradise? A world with oceans, continents, and perhaps a teeming global jungle? What if, deep beneath that infernal atmosphere, lie the melted, scoured, and unrecognizable ruins of a firstborn civilization? A civilization that rose, built, and burned long before the first complex life ever swam in the primordial oceans of Earth. This is the story we are going to investigate, Are we looking at a failed planet? Or are we looking at our own future? So, how do we get from that 900-degree planetary oven back to paradise? Seems like an impossible leap, a complete fantasy. But the story of a planet isn't a snapshot. It's an epic written over billions of years in rock and chemistry. To understand Venus, we can't just look at where it is today. We have to rewind the clock and look at where it was. This isn't hopeful speculation. This is rigorous science, coming from some of the most sophisticated climate models on Earth. Researchers at NASA's Goddard Institute for Space Studies, the same teams who forecast our own climate's future, decided to point their digital time machine at Venus's past. They asked a simple, revolutionary question. What if Venus had an ancient ocean? The answer they found is staggering, and it hinges on one critical, often forgotten fact: star's age. 4 billion years ago, our sun was not the brilliant, scorching engine it is today. It was a faint young sun, nearly 30% dimmer. This cosmic detail changes everything. That faintness, which should have turned early Earth into an ice ball, would have placed early Venus squarely in the center of the habitable zone. Running these powerful simulations, a new world swims into focus. A world that looks nothing like the Hell's Cape we see today. The models show that if Venus had oceans, it could have kept them. We see a planet with vast, shallow seas, perhaps only a tenth as deep as Earth's, but sprawling across its lowland basins. We see large, stable continents, landmasses that would have been islands in a global, temperate ocean. The models also paint a picture of a stable atmosphere, not the runaway beast of today. It was likely thicker than Earth's, rich in nitrogen and carbon dioxide. But this wasn't a flaw, it was a feature. That thicker blanket of greenhouse gases would have perfectly balanced the dimmer sun, creating a stable, warm climate. Think less of a pressure cooker and more of a global tropical greenhouse. But the most shocking part of this simulation isn't that Venus was habitable. It's how long it stayed that way. According to the Goddard models, this placid, ocean-bearing world could have persisted for not just millions of years, or even hundreds of millions. The data suggests a stable, temperate climate for up to 3 billion years. Let's pause and try to wrap our minds around that number. 3 billion years. All of recorded human history is a microscopic speck in that time. The entire age of the dinosaurs, from their rise to their extinction, is just a fraction of that span. Complex, multicellular animal life on our planet only emerged about 600 million years ago. Venus may have had a stable, water-rich climate for 5 times longer than it took Earth to evolve its first complex animal. This single, scientifically backed possibility rewrites the entire story of our solar system. We are conditioned to think of Earth as the cradle of life, the singular, precious, blue marble. But while Venus was potentially enjoying this 3 billion-year summer, what was happening here at home? What was our planet doing during this vast, forgotten eon? The truth is, Earth was the hostile world. For much of this time, our planet was a violent volcanic rock, shrouded in a toxic methane haze, its oceans a murky, iron-green soup. It was constantly bombarded by asteroids, a sterile and chaotic place. Life here was nothing but a fragile film of single-celled bacteria, hiding in the dark, clinging to hydrothermal vents. For a long time, we were the failed planet. This is the paradigm shift at the heart of our investigation. For the majority of our solar system's history, Venus may not have just been habitable. It may have been the most habitable planet in this system. It was the true sister to Earth, but it was the older, more mature sister. It had the head start. The stage was set, the conditions were perfect, and the clock was ticking for 3 billion years. This isn't fantasy. This is the scientifically plausible stage upon which our story is built. A stable, blue Venus, shimmering with shallow oceans for 3 billion years. This is the world our best science now allows us to imagine. But a stage, no matter how perfect, is just an empty room until the actors arrive. If the ingredients for life, liquid water, a stable climate, and organic molecules delivered by comets, were present, what would happen when you add the final, most powerful ingredient of all time? Here on Earth, we've learned a profound lesson. Life is not a delicate, fragile miracle. It is a tenacious, cosmic weed. We find it thriving in the boiling, acidic water of Yellowstone's geysers. We find it in the crushing blackness of the Marianas Trench. It survives in the dry, irradiated valleys of Antarctica. Wherever we find even a hint of liquid water and an energy source, we find life. It seems that life isn't a rare accident. It's a fundamental property of a wet, chemical-rich planet. Why would Venus, which had better conditions for longer, be the sole exception? So let's grant that life begins. What would it look like? On Earth, the great evolutionary leap was photosynthesis, life learning to eat the sun. This is what created our biosphere. But on Venus, the conditions for this process would have been supercharged. It was closer to the sun, bathing in more intense solar energy. Its atmosphere was almost certainly richer in carbon dioxide, the very food that plants breathe. The result wouldn't be a familiar, balanced ecosystem. It would be a biological arms race. This is our central hypothesis. A global jungle. A single, planet-spanning rainforest, thicker and more aggressive than anything we know. Imagine a canopy so dense it creates a second, upper-level world, with a dark, swampy underworld on the surface below. In this hothouse, evolution would be relentless. The competition for sunlight would be a vertical war, driving life to build colossal, continent-spanning structures. It would be a world of biological excess, a planetary engine of growth and adaptation running in overdrive for eons. And what does such intense, relentless competition produce? On Earth, it eventually produced a new kind of survival strategy. It produced problem-solving, produced tool use, it produced social structures, cooperation, and ultimately the abstract thought you are using to process these words right now. Intelligence, for us, was just another evolutionary tool to get a foothold in a competitive world. So, we must ask the question, in a 3-billion-year-old superjungle, what would its version of intelligence look like? They would not be like us. We are the third chimpanzee, creatures of the open savanna, shaped by scarcity and changing climates. They would be a product of the hothouse, of suffocating abundance and ruthless competition. Perhaps they were a social, saurian species that learned to build in the canopy. Perhaps they were an insectal collective that built vast, air-conditioned mounds. Or perhaps they were something so truly alien, born from a biology we can't even classify, that we lack the language to describe them. We call them the firstborn, a hypothetical, intelligent species that rose and built a global society while our own world was still a muddy, bacterial wasteland. Think of the timeline. On Earth, it took nearly 4 billion years to get from the first cell to the first satellite. Venus had a similar, uninterrupted window. What if its civilization rose, matured, and reached its zenith 1 billion years ago? Or 2 billion? What would a society with 1,000-year, a million-year, or even a billion-year head start be capable of? Imagine that civilization at its peak. A global network spanning continents, its structures perhaps biological in nature, woven from the very fabric of the jungle world. They would have studied the stars just as we do. They would have looked out at their solar system, seeing a frozen, dead Mars and a toxic volcanic Earth. They would have analyzed our methane-choked atmosphere and concluded, quite logically, that they were the only intelligent life in the system. They would have been the firstborn, and they would have believed they were the only born. A thriving, intelligent world, existing for a time span we can barely comprehend. A beautiful, bold hypothesis, but it crashes headlong into one terrible, burning fact. The Venus we see today. If a global civilization built a world, what happened to it? If the firstborn existed, where are they? The answer, of course, is that they were erased. And this brings us to the most difficult part of our investigation. How do you find the ghost of a civilization that was burned, melted, and buried by a planetary apocalypse? So, a global civilization of firstborn, existing for eons in a planetary jungle. It's a spectacular, romantic idea, but it runs headfirst into a 900-degree wall of burning, acidic reality. If they existed, where are they? Where are the cities, the statues, the satellites, the bones? The blunt, brutal answer is that they are gone. Utterly and completely obliterated. Imagine our own civilization. Imagine our concrete, our steel, our plastic. Now, put it in a pressure cooker at 900 degrees Fahrenheit, 90 times our atmosphere, and let it bake for, say, 700 million years. Nothing would survive. The metals would melt, the plastics would vaporize, the glass would slump. The very rocks of the continents would melt, reform, and be buried by planet-wide volcanic eruptions. The surface of Venus isn't an archaeological site. It's a geological blender that has been set to high for an eon. So we cannot look for artifacts. We cannot dig for ruins. We must hunt for something far more subtle. We are hunting for technoghosts, anomalies in the data that don't make sense, the lingering chemical and geological echoes of a world that was. And this investigation, this hunt, begins in the most accessible place we have, the atmosphere. The Venusian atmosphere is a chaotic, chemical soup. But it holds one profound, undisputed clue. It is choked with deuterium, a heavy form of hydrogen. This deuterium to hydrogen ratio is staggeringly high, and it is the unmistakable smoking gun signature of a lost ocean. This isn't a hypothesis. It's a fact. We know with scientific certainty that Venus was once a blue planet. The water is gone, but its ghost remains. But there are other, stranger ghosts in the air. The atmosphere is a chemical puzzle that doesn't add up. There are mysterious traces of phosphine, a gas that on Earth is almost exclusively tied to living biology or industrial processes. Scientists debate its existence, but the very possibility is haunting. Then there's the sulfur. The air is full of sulfur dioxide, but it should have all been scrubbed out by the rocks on the surface long ago. Something, somehow, may still be replenishing it. Is this just unknown geology? Or is it the last, lingering exhaust of a biosphere that died horribly? Next, we go to the surface where we can't see but we can map. In the 1990s, the Magellan probe used radar to pierce the clouds and give us our first global maps. They revealed a landscape alien beyond comprehension, featuring structures found nowhere else. Most baffling are the tesserae. These are vast, upland regions, some the size of continents, that are fractured into complex, grid-like patterns, as if a giant had scored the surface in perpendicular lines. Geologists have natural explanations, of course. They call it complex tectonic deformation. But let's ask the forbidden question. What would a billion-year-old, planet-spanning city look like after being melted, crushed, and volcanically resurfaced? What would the foundations of a global infrastructure, built by an intelligence we can't imagine, look like from orbit? Perhaps it would look like strange, unnatural, grid-like patterns in the rock. We see other oddities like the bizarrely circular pancake domes that look almost manufactured. Are we just looking at weird volcanoes, or are we staring at the melted-down ruins of a world so vast they are now mistaken for geology? Finally, we have the only images ever taken from the ground. The heroic, short-lived Soviet Venera landers. These are our only postcards from hell. They show a desolate, orange-lit plain of cracked, flat rocks. The official explanation is simple. It's a field of volcanic basalt. But look closer. Look at the images from Venera 13. The rocks are strange. They aren't jumbled boulders. They're flat, sharp-edged, layered slabs, some looking almost worked. This could absolutely be a natural formation, perhaps a type of laminar basalt that cooled and cracked in flat sheets. But in the context of our investigation, we have to ask, are we looking at the rubble of a natural world? Or are we looking at the melted, eroded, and chemically altered pavement of something else? The unrecognizable foundations of a structure that was never meant for our eyes. None of this is proof. A wisp of gas, a strange-looking mountain, a funny-shaped rock. Individually, they are just anomalies. But taken together, they paint a haunting picture. They are precisely the kinds of evidence we would expect to find. Not a welcome sign, not a shining city on a hill. Just the quiet, unsettling, and persistent chemical and geological questions that refuse to go away. The faint, ghostly fingerprints of a world that was. So we have this image. A vibrant, blue Venus, a teeming global jungle, and a civilization of firstborn that had a 3 billion-year head start. Paradise. But when we look at Venus today, we see a 900-degree furnace. This isn't a transition. It's an execution. The greatest mystery isn't if paradise was lost, but how. How does a world boil? How does an entire biosphere and the intelligence it created get erased from existence? The answer, it seems, lies in the sky. The Great Burning, as we'll call it, wasn't an instant event, but a planetary fever that reached a terminal, breaking point. When we model this collapse, two terrifying possibilities emerge. Two paths to the same hell. One is a story of cosmic fate, an inevitable tragedy written in the stars. The other is a story of self-destruction, a cautionary tale so profound it echoes across the solar system. Let's explore the first path, the slow, natural apocalypse. Our sun is a star, and stars are not static. Just as it was fainter in the past, it has been growing brighter and hotter very slowly for billions of years. It's a relentless, cosmic engine, and its output has been steadily increasing. For Venus, this was a death sentence delivered in slow motion. The firstborn civilization would have been the most advanced astronomers in the system. They would have seen it coming. Imagine their scientists generation after generation, charting the slow, agonizing rise in global temperature. First, their equatorial jungles would have withered. Then, the oceans themselves, those vast, shallow seas, would have begun to steam, loading the atmosphere with water vapor, a powerful greenhouse gas in its own right. This runaway feedback loop was an act of God. The more the ocean steamed, the hotter the planet got, and the hotter it got, the more the ocean steamed. They were, quite simply, being cooked alive by their own star. This is a tragic, noble end. A civilization battling against the inevitable forces of astrophysics. But there is another, darker possibility. What if the sun didn't do it? Or what if the sun merely provided the gentle push and the firstborn did the rest? What if their own success, their own industry, their own mastery of that global jungle world is what sealed their doom? This is the hypothesis of the first climate change. A global civilization, even one woven from biology, would need energy. It would alter its environment. It would build. It would consume. Perhaps they burned the biofuels of their supercharged jungle. Perhaps they unlocked geothermal power, releasing vast plumes of carbon and sulfur that were trapped in the crust. Maybe their mastery was so complete that they paved over the planet, disrupting the natural carbon cycle. The exact mechanism doesn't matter. The result does. For a time, their world's powerful biosphere might have absorbed the shock, just as our own oceans and forests do. But there is always a tipping point, a moment when the planet's systems can no longer compensate for the industrial-scale waste of its dominant species. A moment when the temperature hits a critical threshold, and the oceans themselves begin to boil. It's the same runaway feedback loop, but this one wasn't fated. This one was chosen. This is the Great Burning. We must visualize it. The oceans, now superheated to hundreds of degrees, boil away, not evaporating, but violently flashing into steam, expanding the atmosphere 1,000-fold. This new, dense, water vapor sky traps all heat, pushing the temperature past the boiling point of rock. The very continents begin to slump and melt. Volcanoes erupt on a global scale, not as mountains, but as planetary-wide fissures, belching trillions of tons of sulfur and CO2, turning the sky into a yellow, acidic soup. It is the end of geology, biology, and everything. And what of the firstborn? In their final days, what did they do? Did they build great ships to ride out the storm, only to be crushed and melted? Did they try to flee, launching desperate, generational arcs into the void, knowing their world was finished? This opens a truly wild, provocative thought. If they tried to escape, where would they go? To the frozen, red wastes of Mars? Or, perhaps, to the one other world that was just beginning to cool down, a world now teeming with simple, single-celled life, our own planet Earth. Is it possible? Are we the descendants of Venusian refugees? It's a profound, unprovable idea. But perhaps a more terrifying thought is that they didn't escape. That they all died there, suffocating in their own sky. Whether their end was fated by a star, or hastened by their own hands, The result is the same. A civilization millions of years old vanished. They left behind a monument, a 900-degree, acid-washed tombstone, hanging in our sky as a warning. And so we return. We pull back from the 900-degree, crushing hellscape of Venus, back through the acid clouds, back across the 26 million miles of empty space. We come home to our own world, a planet of deep blue oceans, white swirling clouds, and continents green with life. This is the pale blue, the singular, precious cradle of our existence. But after this journey, it's impossible to look at it in the same way ever again. For all of human history, Venus was just a light, the morning star or the evening star, a symbol of beauty, mystery, and the gods. When our probes finally pierced its veil, that beauty was shattered, replaced by a new story. Venus, the failed Earth. The cautionary tale of a planet that formed just a little too close to the sun. A sterile never was. It was a comfortable, tragic story that placed us, the survivors, firmly at the center of a fortunate universe. But what we have investigated today is a far more terrifying and far more plausible narrative. What if Venus isn't a failed Earth, but a finished Earth? A world that had its chance, had its 3-billion-year paradise, had its own teeming global jungle. A world that, perhaps, even gave rise to its own intelligence, the firstborn. And a world that, in the end, burned. The mechanism of its death, the runaway greenhouse effect, is not some exotic alien force. It is the exact same fundamental physics that is operating on our world right now. We are pouring carbon dioxide into our own atmosphere at an unprecedented rate, the industrial exhalation of our entire global civilization. We are, quite literally, running the same planetary experiment that turned our sister world into an uninhabitable furnace. We are just in the earliest, most comfortable stages. We don't know if the firstborn, if they existed, had a choice. Perhaps they were the blameless victims of a slowly brightening star, a cosmic fate they were powerless to stop. But there is that other, darker possibility, the one that haunts this entire investigation. What if their own success, their own industry, their own mastery of their planet is what lit the match? What if they were too successful, too consuming, too slow to see the tipping point until it was too late? This hypothesis offers a chilling potential answer to one of the most profound questions we have ever asked, the Fermi paradox. Where is everybody? We've been scanning the cosmos for decades, listening for the signals of star-spanning empires. We've been met with nothing but a great, cosmic silence. We've always assumed that intelligence is a ladder to be climbed, that its inevitable endpoint is to conquer the galaxy. But perhaps Venus is the answer. Perhaps intelligence is not a ladder, but a trap. A brief, brilliant, and ultimately self-limiting phenomenon. What if the universe is full of life, and what if intelligence rises all the time? What if it always discovers fire, industry, and physics? And what if, almost every single time, it fails to survive its own success, burning itself out on its own home world? The great silence, then, isn't the sound of an empty universe. It's the sound of a galactic graveyard, filled with the ghosts of civilizations that couldn't pass the final test. That bright, beautiful star in our twilight sky is no longer just a planet. It is a mirror. And looking into it, we are no longer looking at an it. We are looking at an us. An us from a possible future. It is the ultimate memento mori, a 900-degree tombstone hung in our sky as a perpetual warning. It is the final, silent scream of a world that died by fire. The silence from Venus is the silence of a biosphere that has been boiled away, of oceans turned to acid vapor, of cities melted back into geology. And it forces us to reframe our oldest question. The question is no longer, are we alone? The question is, are we next?